Section 8.2, Graph of Polar Equations. We've gone over graphing some basic polar equations. Here is another one with r equals 3. This is simply a circle with a radius of 3. You can see that we're using a different graphing grid that has special angles and radii of 1, 2, 3, and 4. This is the polar coordinate plane. Let's sketch r equals 2 plus 2 cosine of theta. This equation graphed on a Cartesian coordinate over one cycle is the graph of cosine stretched by 2 and shifted up by 2 units. Reading values off of this graph, we can plot points on the polar coordinate plane. So the graph started at r equals 4 when theta was 0 and curved to r equal 2 when theta was pi over 2. At theta equal pi, r went to 0, and at theta equal 3 pi over 2, r went back up to 2. And at theta equals 2 pi, r became 4. Note that this cycle repeats. This is called a cardioid as it looks like a heart. Let's graph r equals cosine of 2 theta. Because of the 2 theta, we have 2 cycles of cosine's graph in the interval of 0 to 2 pi. Let's use the labeled points to graph this equation in polar coordinate plane. If you notice, point 2 goes to the third quadrant because r is reflected into the origin since it is negative. We can trace all the points and see how they correspond. This is called a four-leaved rose. Here are some polar graphs to look at their symmetries. In the past, we discussed symmetry with respect to x-axis, y-axis, and origin. In polar coordinate plane, horizontal axis is called the polar axis, vertical axis is the line of theta equal pi over 2, and origin is the pole. Therefore, we have symmetry with respect to polar axis, pole, and line of theta equal pi over 2. The same method of symmetry that we covered in earlier chapters can be used here. The graph of the equation r of theta is symmetrical with respect to the polar axis if r of theta equals r of negative theta, the pole if r of theta equals negative r of theta, or equal to r of theta plus pi, and the line of theta equals pi over 2 if r of theta equals r of pi minus theta. Let's sketch r equal 1 plus 2 cosine of theta. By using symmetry, we find r of negative theta, which equals to r of theta since cosine is positive in the first and fourth quadrants and negative in second and third quadrants. However, pi minus theta gives angles in second quadrant first and then first quadrant, which results not to equal r of theta. Therefore, r of theta is symmetrical with respect to the polar axis. Finding the coordinate values for the special angles, we have this table. Using the symmetry, we can find the rest of the points. The symmetry can be seen using the Cartesian coordinate graphing. Using these values, we can graph this equation on the polar coordinate plane. Here are some more polar curves. These are suggested textbook homework problems and required ALEKS homework for section 8.2.